Good evening. Welcome back to AP Stats Notes Online. Want to move the conversation to linear transformation, transforming a random variable. In class, I gave you the additional note sheet because, like I said, in this section of your notes, which is the next section we would be talking about, walks you through how to transform just a regular variable. And you already know that. We've talked about that. We talked about that in Chapter 2. So it might be a nice review. It may be at the very beginning of class on Monday. We'll walk through what you should get for your new mean and standard deviation for this situation here, which is talking about the employees at a company and their monthly salaries. I'll get you... well, here, I've got the mean and standard deviation for you. I'll write that down, and you can find the new mean and standard deviation based on a couple of different circumstances, and we can check to make sure that you still remember how to do that. Okay, so the mean salary for the employees of this company, I'll let this come up real quick, is $1,542.86. So $1,542.86. And again, you can get this by just typing this into a list and doing a one variable stat just on that list. You don't need a frequency list if you're going to just list out all of your values, because we don't know, we're not showing the calculator how often they occur. But anyway. And then the standard deviation is $720.81. So in this instance here, where they're giving everyone a $500 raise or cutting everyone's pay by $500, what will happen to the mean and standard deviation? You should be able to remember how to do that, and so there'll be a nice review. So give that a shot and see what you come up with. This constructing parallel box plots is just want you to talk about shape. And so I'll just write out here what happens to shape. When we add a constant to all of our values, what happens to shape? You're going to talk about what happens to mean and standard deviation already, what happens to shape. And then this down here has you write out the rules. What happens to mean, standard deviation, and shape of a distribution if a number is added or subtracted, right, to each data value. And then the next section of these notes talk to you about if you just give everyone, instead of giving everyone a flat dollar amount raise or cut their pay, what would happen if you gave everyone a 30% raise? And so you have to remember that what that means is whatever their salary is, if it's like $500, then if they get a 30% raise, it's the same thing as multiplying it by 1.3, right? That's 30% more than what they were making. And so again, what happens to mean and standard deviation? You should know that already. And again, instead of constructing these box plots, what happens to shape? Okay, so I'll let you work those out real quick. Shouldn't take you long. And then, like I said, on Monday, beginning of class, we can throw these rules in real quick and move on with our lives. Okay, that being said, I want to get to random variables. And so this isn't talking about random variables. I want to show you what happens to random variables. Okay, so in the sheet that I handed to you, that it may be in the back of your notes now, but let's talk about that. So suppose we've got two random variables, x and y, and the probability distributions are given as such. For x, x could be 2 or 3, and then the probability is assigned. Y could be 4, 5, and 6, and the probability is assigned there. Now, like we talked about in class, we can come up with the mean, and that's what we want to do. We want to come up with the mean, the variance, and the standard deviation for each of these. And then we can talk about what happens to those calculations as we do different things to our random variable, multiply by a constant, add a constant, things like that. So we're going to find the mean, and we're going to find the standard deviation, and we're going to find the variance. So again, quickly, you can type x and y into two lists, and then do a one variable stat where your list It's just going to be your variables, your value of your variables, and then your frequency list will be your probabilities assigned to each. So type those in, and it should look something like this. Okay. It should look something like that. Actually, I think these probabilities are wrong. But anyway, go ahead and type those into your list. Come up with the mean, standard deviation, and variance for these guys. You can stop the video, work those out, and once you have those calculators, start the video again. I'll show you what you should have come up with. All right, so is this what you got? Should have gotten 2.75 for your mean on X, 0.1875 for your variance, 0.433 for your standard deviation. For Y, the mean is 5.2, the variance is 0.76, and the standard deviation is 0.871. Okay? Hopefully that's what you came up with. If you didn't, come talk to me. We'll figure out why, especially if you're still a little shaky on using the calculator. If you're not quite there, I know you 7th period folks, we didn't get a chance to really go through that in great detail. Page 348 in your book would walk you through that. So anyway, that's what you should have come up with. Even if you couldn't use your calculator, you should have been able to do it by hand pretty quickly. All right, so let's take a look at what happens when we start manipulating some of these variables, right? So first and foremost, what if we multiply our random variable x by 3? If we take all the values and multiply by 3, right? So then our possible values for x, instead of being 2 and 3, become 6 and 9. How does that affect our mean and standard deviation? Okay? We'll go ahead and calculate those out. And again, I'll give you, take your time to do that, and you can stop the video if you want, find out what you got, and I'll show you what I get, and then we talk about the results. Okay, so did you get 8.25 for your mean, 1.6875 for your variance, and 1.3 for your standard deviation? And if you're wondering why we keep carrying variance through, you're going to find out when we start combining random variables why that's important. But for right now, it may not make a lot of sense, and that's okay. Just kind of roll with it. But so the question becomes, what happened to the original mean on x when we multiplied all of our values by 3, when we transformed by multiplying by 3? Well, our original mean was 2.75, and now it's 8.25. So how much bigger is the new mean, right? It's obviously bigger. How much? So the old mean was 2.75. Well, you could subtract them, and you end up getting 5.5. That number doesn't mean a whole lot. That's the difference between the two. We can also figure out if 2.75, if the old mean was increased by a factor. So we could take 8.25 and divide it by 2.75. And when you do that, 8.25 divided by 2.75, you get 3. That means that our original mean of 2.75 for x, apparently we multiplied that by 3 to get to 8.25, which should sound eerily familiar, right? Before, in our regular variables, if we multiplied all of our values by a constant, then that changed the mean by simply multiplying by that constant. Okay? And the same thing happens here. Having probabilities attached doesn't really make a difference. We're still going to multiply our measure of center, which is our mean, by the same number that we're multiplying all of our variable values by. Now the same thing with our standard deviation. If we take 1.3 and we divide it by the standard deviation we got before, which was 0.433, right? We do that, and you get 3. Now, maybe not close, maybe not exactly 3, but that's because of some rounding. So, but you're going to get pretty close to 3. So apparently, standard deviation is affected the same way. If I multiply my values by 3, then I multiply my original standard deviation by 3 to get the new standard deviation. Variance, we need to take 1.6875 and divide it by 0.1875. And if you do that, 1.6875 divided by 0.1875, you get not 3, you actually get 9. Okay? Which means that the variance increased by a factor of 9. Now that should make sense. Since variance is standard deviation squared, and the standard deviation went up by a factor of 3, then the variance is going to increase by a factor of 3 squared, which is 9. Okay? So actually, you know what? Everything seems to be the same as it was before. Okay? Now, you can verify this if you want. We can check it for y, but the same is going to happen for y. If I multiply all of my y values by 5, before for regular variables, and then apparently now with random variables, the rules are the same. If I multiply all of my possible values for y by 5, I get 20, 25, and 30, the probabilities don't change. The mean is just going to go up by a factor of 5. So I need to take 5 and multiply it by, the original mean on y was 5.2. Okay, and you can verify this. Type these two lists into your calculator, do a one variable stat, and you're going to see that the mean is actually 26. Okay, pretty sure. And then to find the new standard deviation, I would simply take the old standard deviation and multiply it by 5. Right? And so that old standard deviation was 0.871. Okay? And when you do that multiplication, you get 4.355. Okay? Now, variance means we have to take the old variance and multiply it by 25. Right? Remember that variance is standard deviation squared. Since the standard deviation goes up by a factor of what we're multiplying by, variance goes up by that squared factor. So we would just take 0.76 and multiply it by 25, right? And so you should get 19, exactly. And so I challenge you to go ahead and type these values into two lists, do your one variable stat on these two lists like page 348 tells you to, or like we talked about in class, and you'll get these values for the mean and the standard deviation. You won't see variance, but for the mean and standard deviation, okay? Now, question is, what if we start adding constants to stuff, right? What if we start adding? So the next situation here has us taking x, multiplying it by 7, and then adding 2 to it. Right now, this is all very generic, and there's no context. When we apply context, there's no difference. We just got to figure out what's happening to our random variable, what are we multiplying by or adding by, and then we can apply our rules. So let's take a look. If you multiply all of your x values by 7 and then add 2 to them, you're going to get 16 and 23 for those new possible values for x. What ends up being the mean, the standard deviation, and the variance? Now, since we don't have an idea of what adding 2 will do to our mean, standard deviation, and variance, why don't we go ahead and use our list to tell us what those values are, right? So go ahead and use your calculator and find the mean, standard deviation, and variance. You can stop the video, and then again, you can always check your work. Once we start it back up, I'll show you what you should get. Okay, did you get this? Did you get 21.25 for your mean? Did you get 3.03 for your standard deviation? Did you get 9.1875 for your variance? I hope you did. If you didn't, again, come talk to me and we'll figure out why. But that's what you should have gotten when you did 16 times 0.25 and 23 times 0.75 and add them together is what you should have gotten 21.25. And then when you go through your standard deviation or your variance formula, you should get these values over here. Okay? So let's take a look and see how this compares to your original mean, standard deviation, and variance, right? You have to remember that, well, we have it up here. The original mean was 2.0 2.75. Now, we already know that when we multiply by a constant, our mean goes up by the same factor. So when we multiply by 7, we need to multiply 2.75 by 7. So 2.75 times 7 gives us 19.25, which is not quite 21.25. What do I have to do to 19.25 to get to 21.25? I have to add 2 to it, which is what we're also doing to all of our values of our random variable. So apparently the mean is affected by multiplication and addition, which again should sound eerily familiar. That's exactly what happens to the mean if we multiply and or add constants to our regular variable. It's no different. So we multiply and then we add. Now take a look at your standard deviation. Your original standard deviation was 0.433. Now we already know that we're supposed to multiply that by 7. 0.33 times 0.433 times 7 gets you, looky there, if I multiply this by 7, I get 3.031, which exactly is what my new standard deviation is, without having to add the 2 to it. So that means that our measures of spread, our standard deviation, must not be affected by this adding 2, which again is the same rule for our our regular variables, right? Multiplication affected spread, but addition did not. Multiplication and addition affected center. So variance, all right, well, we're kind of following the same rules here. That means I must take my old variance, 0.1875, and I have to multiply it by, well, since variance is standard deviation squared, I must have to multiply it by 7 squared. So 0.1875 times 49 gets me my 9.1875. Okay? So bottom line is, it's the exact same rules for regular variables. Random variables follow the exact same rules. If I'm going to multiply all of my random value variables by a constant and then add a constant to it, then I have to take my old mean, multiply it by that same factor b, and add a to it. For variance, now this is variance, so apparently I take my old variance and multiply it by, not by b, but by b squared. Again, because it's the standard deviation squared. And therefore, to find my new standard deviation, I would take my original standard deviation and simply multiply it by b. You don't have to worry about adding the a to it. Okay? It's the same rules as before. Not a big deal. Okay? When we start combining random variables, we need to sort of figure out what situation calls for that, and then what happens to our means and standard deviations from there. Okay? We'll discuss that on Monday night's notes. For now, that's it. The last question here is, do these rules hold for finding the mean and variance of 3 plus 2y? I'll let you try that and see. The rules should hold. So I would do this 2 different ways. Find the mean on y and the standard deviation and variance on y, and apply our rules here, and then do that, and then actually do that to your values on y. Take, 4, 5, and 6. So 4, 5, and 6 times 2, and then add 3 to them, and then do those in your list and see if you get the same thing. You should. It'll follow the rules. Okay? That's it. We'll stop the notes here. You have some homework that you can work on if you want. And then we'll take a look at what we need to take a look at on Monday. Have a good weekend.